Hello and welcome back to part two. Talking about network management. We left off here, so let's keep going. Um, this is just a simple decision matrix. A decision matrix can get very long and very complicated. It's something you would do in Microsoft Excel. And if it's a really complex decision, like building a data center from scratch, you're going to send out an RFP, which is a request for proposal. If it's a smaller project, maybe an RFI, or request for information. But an RFP is a very long document. This is why business writing is so important, especially in networking. You're going to write that RFP that's going to outline all of the business requirements, the business problem you're trying to solve, and then all of the technical requirements, all the specifications for bandwidth, for availability, what kind of budget you're trying to stay under. You're going to include a network diagram in your RFP. Otherwise, that's the first thing the vendor's going to ask you for, right? Is, can you show me a diagram of what you're looking for? All of that goes into your RFP. I've seen RFPs that fill binders, 3-ring binders that are 2 inches thick. So an RFP can be daunting. It's a lot of paperwork. But you submit that, but you're spending millions of dollars. You submit that RFP to, you pick your top 5, maybe top 10, but keep it low, like 5 to 7 vendors. The best vendors out there. Do your research from Gartner, Forrester, PricewaterhouseCoopers. Get the top vendors in that area. Get them to respond to your RFP. They do that for free. They're bidding on the business. And they'll send their response document back to you. And then you compare all the response documents, and then you start filling in your decision matrix. That's how business works. I know you all want to play with technology, but that's like 20% of what you're doing as a network engineer. A bunch of it is business, and a bunch of it is administrative stuff, and a bunch of it is still paperwork. But any job is like that. But you do get to play with technology. That's what makes it a cool job. So anyway, documentation is important because you're writing up business requirements clearly and articulately. You have to write that project charter, especially if you're a project manager. You may have to write the request for proposal, certainly not as a junior person, but you might have to add sections to an RFP. You may have to write an SLA, and if you have to write one from scratch, that's why I gave you some links to show you what SLAs look like. You might have to write up procedure documents for here's how you configure this router, here's how you troubleshoot this switch within your organization, here's how you set up this VPN tunnel within your organization. You definitely need to know how to do a good network diagram. So there's a lot of writing involved. That's my point. Okay, here's the third one. Remember, we talked about speed, number 1, and then availability, number 2. Finally, cost is the third area of network design that we want to look at. And this is a difficult one to measure specifically because there's so many different costs. And if you look through the whole SDLC, Systems Development Lifecycle, which we probably covered in a different class already, Systems Analysis and Design, for example, throughout a project implementation, there are a lot of different costs. Development costs, soft costs, of course hardware and software and service and labor, training for your system administrators, maybe it's training for your end users, although in our case, probably for the network administrator. There are a lot of costs. Not all of them are obvious. The best way to approach cost, I think, is through looking at TCO. TCO is an acronym that cuts across all functions within information technology, as well as all functions across every business unit, everywhere. So somebody in accounting, and finance, and marketing, and HR, they're going to know what you mean when you say TCO. In fact, they're going to know you're smart, and you're looking at the right things if you throw around that TCO acronym. It has nothing to do with technology. It has everything to do with making sure you're including all the types of costs, all the hidden costs. You're not going to get surprised by anything. Oh, I forgot to include tax. Oh, I forgot to include shipping. Oh, I forgot to include we're going to have to hire a contractor. Oh, I forgot that we're going to have to buy another server for this. Oh, I forgot that we're going to have to hire another help desk person to field phone calls for this new application. Oh, I forgot. It's to avoid all those oopses if you use the TCO model. I've used it for years. It's been around for a while, but it's still very popular. Okay, you've wrapped up your design, you're ready to pull the trigger, you've set up your new network, it's up and running, you've paid for everything, it's up and running. Now what? Well, now you have to go into day-to-day operations, right? You have to support the thing. Once you set up a network, the work doesn't end. The fun just begins, because now you've got users connecting to it and flooding with all kinds of traffic, either appropriate or inappropriate, and you've got to stay on top of filters and ports and access control lists, and make sure that people have access, role-based access to just the things that they need access to do their job. The book says this is, whoops, let me switch back over to PowerPoint. Okay, that was my video that was getting published on YouTube. The book has this awful acronym called OAM&P. I've never used this acronym, but I'm very familiar with the idea, and every business has this idea of ongoing operations. Keeping the lights on is what we called it at Lowe's. But it includes operations, administration, maintenance, provisioning. Provisioning is a fancy word for setting up new user accounts or setting up new locations as we onboard new locations or new employees. When you bring down a site, that you're closing down a site, you have to deprovision everything. You don't want to keep paying for bandwidth to a site that you don't even use anymore. Similarly, you don't want to pay for licenses for users that are no longer employed. So you need a provisioning and deprovisioning process as part of operations. Finally, network management itself, you're going to use a whole tool set of pieces of software to keep an eye on your network. And your last homework assignment will have more to do with different network tools. But for now, you need some kind of tool. You're going to have like 6, 10, maybe even 20 different pieces of software in your toolbox. But one of them has got to be a piece of software that understands SNMP, Simple Network Management Protocol. This is the lowest common denominator. And just about every single managed router, managed switch, managed access point understands SNMP. That's your baseline. It's got to understand SNMP. So your network management software, whatever you use, this might be HP OpenView, it might be something cheap like SpiceWorks, it might be IBM's Tivoli, I think they still make Tivoli, it might be, what are some other big names? We'll talk about this in class and see what you guys use. Different shops use different network management software. No matter what it is, it's going to use SNMP to talk to an agent, not the device. SNMP has no way of communicating directly with a switch. All it can communicate with is the agent, a piece of software, really firmware, running on the switch that's communicating directly with the hardware. So the hardware says, port number 6 is down, and I don't know why. And the agent gathers that information. The manager talks to the agent. Do I have to say that 3 times again? The manager talks to the agent. Great test question. Great certification question. And remember, I was trying to draw this bizarre analogy in class of how this is almost like a distributed denial of service attack for good, where you've got instead of an attacker, you've got a manager sending out instructions to agents instead of bots. But architecturally, it's exactly the same thing. You're just using it for benefit to the organization. But it's the same sort of technology anyway. Maybe that's too esoteric a point to make. But SNMP, the agent, what it's doing is it's setting alarms to the manager, and so you set up your management software. If this particular router goes down, send me a text to my cell phone immediately. Or if this interface goes down, just send me an email. You're going to configure your alarms. But we don't call them alarms. Why? Because we're network people and we call them different things. We call them traps. They're SNMP traps that are sent to the manager, and then the manager pages you, emails you, calls you, whatever it's set up to do. Or maybe just logs it. You check the log every so often. It's really up to each network administrator to figure out how they want to set things up. And the other just kind of a good acronym to know with SNMP is the agent is updating the MIB, the Management Information Base, which is just a database of information on the manager. But anytime you're talking about SNMP, you're you're gonna, if you're looking at a new router and you want to know if it's compatible with your network management software, all you need to do is ask the vendor, is it in the MIB already? Will the MIB understand it? And they'll go, yes, it's already in there. Okay, good. It's almost like Microsoft Windows already understands, a whole host of printers, even though you may not be connecting, 1,000 different printers to your system. Windows knows about all those. Well, the network management software knows about a lot of different devices in its MIB. That's one way to explain it, I suppose. So now we come to Tim's principle of good network design number 2, which has to do with you wanting to be at home, remotely managing your network, not having to drive into the office, not having to walk into the data center and look to see if lights are flashing or what's down on your network. You want to be able to do that remotely for a variety of reasons. And maybe you don't even want to be able to do it from home. Maybe nowadays you want to be doing it when you're traveling, you want to do it from your smartphone. This is part of network management, and you want to design this from the very beginning. You want to design for remote management, and then especially for out-of-band management. What I mean by out-of-band management is, say the network's down. How are you going to connect to the network if the network's down? How are you going to VPN in if VPN is down? How are you going to dial in if the modem's down? Well, you need some kind of backdoor, which means some kind of alternate way, some out-of-band. It's outside of the normal bandwidth, outside of your local area network, a backdoor into your network to get into it when the poop hits the fan. There are a couple ways to do this. One is with good old-fashioned modems. It's old-fashioned technology, but it works. You plug your laptop into a phone line, dial into a modem in the data center. It connects you into a separate connection into the router. It's out of band. You can connect to the router and see what the heck is going on and start rebooting things, even though the network's down. That's how you appear to be a wizard to end users, because you have these magical backdoors. Another way to do it, and this is just fantastic, is using lights-out boards. Compaq developed the trademark name lights-out board, but Dell has something similar. Most servers come out with some kind of lights-out technology, and I've just got a couple of minutes. Some kind of technology that it's a separate card you slide into your server, and it's got an additional network card so that you can remote directly into that box rather than going through the network. It's got its own dedicated network connection on the lights out board. It's running a little processor on there so that even if that server is turned off, you can still connect to that server remotely, sitting at home, and power up that server or reboot that server remotely. That is freaking magic stuff. Lights out board is something that you want to build into all of your servers. It's maybe $300 additional for each server. You've got to do it. This is what's going to save you a lot of heartache. So the last thing that I can squeeze in here is you are going to go and look at this PDF, read through it, because I really need you to understand the difference between a managed switch and an unmanaged switch. Okay, a managed switch costs more money, and you're going to have to explain to somebody in accounting why you're spending $600 for a switch instead of $200, or $1,000 instead of $500. This document will help you understand the difference. I strongly recommend that in all your network designs you always use a managed switch. Other faculty will tell you differently. They'll tell you to save money and just get an unmanaged switch. In my experience, that's not the right way to do business. Spend a little more money up front, get a managed switch so you can do everything remotely. Okay, that's the end of network management. Thanks.